Good morning friends. This is series of lecture for T.Y.B.Sc Analytical chemistry student. The chapter we are going to study is chapter number 6, flame emission spectroscopy, and the course number or the course of the subject is CH611A. Now in the previous lecture we have already learned about the calibration curve method. Now in this lecture we are going to study the standard addition method. Here alkali, alkaline earth metals and rare earth metals are quantitatively determined by flame photometry. Now here flame photometry is being used for qualitative analysis and quantitative analysis. For qualitative analysis, wavelength is used. From the wavelength we get the information about the what is the element is present, that is a qualitative analysis, and that intensity of the wavelength, intensity of the color gives the quantitative estimation, that means how much the amount is present. And here flame photometry is used for alkali metals, alkaline earth metals and rare earth metals. There are three methods by which quantitative estimation has to be determined. That is nothing but the method of analysis. And in the last lecture we have already learned about the calibration curve method. Here the calibration curve method, in that series of standard solutions are prepared and unknown concentration is also prepared. That unknown solution having unknown concentration is also prepared, and their corresponding intensity is measured and the graph is calculated. Here blank solution, that is a solvent, its intensity is also to be determined, and we get the graph having the nature a line which is passing through the origin with slope y is equal to mx plus, so m is the slope. We get the knowledge about we get the value for the y. Then we put the value of y into that y is equal to mx. We know the slope from the graph, and just we calculate the x, and that x is nothing but the unknown concentration. So that is all about the calibration curve method. Now here in this lecture we are going to understand what is standard addition method. What is a standard addition method? Now here we will focus on the standard addition method. The first point is that in this method unknown solution and unknown solutions plus varying amount of standard A is prepared. So the first point is that series of solutions firstly prepared, but in that first is unknown solution, and from the second with that same amount of that is unknown solution is added in the next solutions which are starting from the solution number 2. In that solution number 2 we just added a standard substance. That standard substance is nothing but the A, and we take the addition of that A within multiple proportion. So that is all about the elaboration of the first point. That first point tells us that in this method unknown solution and unknown solution plus varying amount of standard A is prepared. The second point elaborates that first of all intensity of unknown solution and unknown solution plus varying amount of standard A is recorded. Now here simply representation that x is nothing but the unknown solution, x plus A, that is the x plus A means what? Just unknown solution plus standard addition, that is A. Now A is get here replaced by 2A. Here 2A is replaced by 3A. That means we just add that A in multiple proportion. So here second point is that first of all intensity of unknown solution and unknown solution plus varying amount of standard A is recorded by aspirating them into the flame. We just aspirate that solution into the flame, but that solution is consist of unknown solution with unknown solution plus varying amount of standard A. That is important. The third point is that the graph of intensity against concentration of unknown solution and unknown solution plus varying amount of standard A is plotted. So here simply we just plot a graph of intensity versus concentration. The fourth point is that while employing this method, a correction should be made. So here this is important point, how this correction is to be removed. While employing this method, a correction should be made for background emission from the flame. So for background emission from the flame, the correction should be made. This can be done. How this can be done? Now here this third and this fourth and fifth point is us about the how the correction should be removed or resolved from the flame. Now here fifth point, this can be done by injecting the solvent into the flame. Just we inject the solvent into the flame and record its intensity, and during that calculation, intensity of that background emission. Intensity of background emission means what? That simply intensity of solvent. So during calculation, intensity of solvent or intensity of background emission must be subtracted from the emission due to the sample or intensity obtained from the sample. We just take a subtraction, we just take a minus, that is nothing but the background emission minus emission due to the sample. Now what are the advantages? First is that very low concentration of the element present in the sample can be determined. Here the standard addition method has very important, it is very advantageous because of very minute concentration of the element present in the sample that should be determined. The second point is that this method is used to estimate a rarely analyzed element. So though elements which are not analyzed by any method, this method, that is the standard addition method, gives the way for the analysis to the rarely analyzed element. Now this is the graph which is obtained from the standard addition method. Here this is nothing but the zero line, and that zero is line is nothing but the here this point indicates the unknown solution concentration or intensity of that. Here this is the multiple concentrations which are added into the unknown solution with the proportion of A. This is the A, this is the 2A, this is the 3A, this is the 4A, and this is the 5A. So multiple concentration of A is get added into that unknown solution. So this should be the X plus A, X plus 2A, X plus 3A, X plus 4A, X plus 5A, and here we get the intensity due to the sample, or you can say unknown solution having the unknown concentration, and we just take a segment line, or we just take a extrapolate to this line to this x-axis, that is a concentration axis, and we get this point. This point indicates the concentration of X. This point indicates the concentration of X. This is the intensity due to the unknown concentration. This is the intensity due to the multiple concentration series, and we just extrapolate line, and here the point, this point indicates simply the unknown concentration for the for the sample solution, and just this is obtained by the standard addition method. So this is all about the information of method of analysis by the standard addition method, how the flame photometry uses the standard addition method. With this content, I conclude this lecture. Thank you very much for your patience listening.